In our first The False Narrative video, guided by the 1990 article Investigate Chernobyl, written by Chernobyl liquidation veterans and various nuclear power plant workers, we discussed why the Chernobyl disaster is grossly misremembered. In the formative months and years of the public Chernobyl narrative, Soviet nuclear power experts, without providing operating documents, portrayed the actions of reactor 4 operators as consisting of a series of severe operating instruction violations, so extremely improbable that Soviet nuclear power experts could not foresee the need to provide protection systems resilient enough to withstand such absurd behaviour. This is literally what Soviet nuclear power experts put down in writing to the International Vienna meeting of 1986, and expressed in oral statements, including this gem found in Adam Higginbotham's Midnight in Chernobyl, the untold story of the world's greatest nuclear disaster, on page 276. Pressed by reporters on the disadvantages in the reactor design he had mentioned, Legasov replied, "The defect of the system was that the designers did not foresee the awkward and silly actions by the operators." Most people believe the defect of the system Comrade Legasov was hiding was the positive scram effect associated with the design of the graphite displacers of the control rods. What most people clearly don't realise is that Valery Legasov was lying about practically everything. This is where we examine the lies that Legasov popularised to ironic fanfare. Liars can be confused for truth-tellers. Legasov was promulgating an entire crafted narrative. Its goal was to largely, if not entirely, absolve Soviet nuclear power experts, whom Legasov represented, and conversely to lay the blame on the operators. It's important to examine this narrative because its purpose endures. The Chernobyl operators, whether represented by an individual figure like Deputy Chief Engineer Anatoly Dyatlov, or more collectively, are remembered as largely causing the Chernobyl disaster. The defense of the operators chiefly lies in the operating instructions and logs, the very documents American experts noted their Soviet counterparts did not provide. We discussed the topic of the operating reactivity margin, or the number of control rods left inside the core, noting the ridiculous number of withheld and distorted details that paint a much different picture of what this parameter actually was, and how the particular operators in the control room on the night of the 25th into the 26th of April 1986 treated it. We highlighted that the actual number of control rods present in the reactor core when that number mattered to the initiation of the disaster is actually unknown, and was certainly higher than the 6 to 8 figure Soviet experts managed to sneak past most. It is possible that the reactor was destroyed with an ORM within regulation. Next, we move on to discuss the rest of the salient points of the Soviet expert narrative that they themselves chose to feature. But before we do that, let us address something. Some of our viewers are wondering who we are, why we should be trusted. We aren't experts of any sort. We have no background in nuclear energy or even engineering more broadly. Who we are is literate and ironically patient, two qualities that are necessary to sort through lies. Doubting us personally is one thing. Doubting our sources is another altogether. Here we have a viewer who derisively puts our sources in quotation marks. This perceptive specimen has apparently read the video description we ourselves wrote. He notes that there are multiple links in it, but only because they lead to the same article text in different formats. Indeed, we see the multiple links to the article text we are explicitly following in this series of videos. There is, however, another link in the description. This is a 178-page paper, long enough to be a book, we've been told, containing 432 citations at present. The author found doing a bibliography unnecessary, so a reader has to settle for all the direct references. Following a 3-page introduction, the first section of this paper is called Lies. It goes from page 4 all the way to freaking page 54. By the time you get to the end of this section, you're in 146 citations deep, or 14.6 inches for anyone who doesn't catch our drift. For most of this paper's existence, there was not a single reference to the article we're currently following. Currently there are like 2, if not 1. We'll let you in on another open secret. We're basically recycling content. We've already gone over the stuff found in this article, without knowing of its existence. When we first encountered the article, we ignored it because it contained very little new to us. When Alexander Kupny did a 2-hour video reading it, we decided we were going to do some videos on it as well. That's it. What were the sources we were using instead of this article when we previously covered this content? They were chiefly the 3 hallmark expert reports discussing the causes of the Chernobyl disaster. The 1986 Soviet expert report submitted to the Vienna meeting, the international INSAG-1 report that resulted from the Vienna meeting, the Soviet report and subsequent discussions, and the later INSAG-7 report that is literally the top source on the causes of Chernobyl. Somewhat flawed and incomplete, though it may be. After all, we have to make some contributions ourselves. In notable addition, we also intersperse Politburo session notes that elucidate some of the hijinks Soviet nuclear power experts were up to. Anyone who is dissatisfied with the lack of prominence, pertinence, authority, expertise, or whatever the hell else of these sources, should seek the professional help we quite simply cannot give. Maybe plainly difficult, or another YouTuber has supreme qualifications that supersede those of the people involved in our sources. At that point, you might as well ask them if they're related to Jesus, and when this world's climax is coming. And so, with profound disappointment, we go back to discussing the article that is underwhelming our viewers. In this video, we shall limit ourselves to discussing the half-truths of Chernobyl. Allegations 2 and 3, made by Soviet experts against the operators, are notable for being able to be read as truths. The article authors immediately acknowledge this. The operators did lower the reactor power beneath the 700 to 1000 megawatt range written in the testing program. In fact, they initially did so intentionally. It's the context where things diverge dramatically between the Soviet expert narrative and the truth. In operating instructions and regulations, there was no such thing as a restriction on operation of an RBMK reactor under 700 megawatts before the Chernobyl disaster. In fact, the article authors show multiple examples where the operating instructions explicitly called for reactor operation under 700 megawatts. Explicit permission to operate under 700 megawatts and lack of any restriction on operation under 700 megawatts is found in INSAG-7 as well. Then the article authors point something out that INSAG-7 at most leaves implicit. The 700 megawatt power figure found in the testing program was written there by the operators themselves. They were the authors of the testing program. It gets even better. Anatoly Dyatlov, one of the deputy chief engineers of the Chernobyl nuclear power plant at the time of the disaster, wrote 2 articles published in Nuclear Engineering International. In one of them titled "Why INSAG Has Still Got It Wrong," Dyatlov announced that he personally set the 700 megawatt power level when he drew up the testing program. This figure had no general safety significance, which is why it was nowhere to be found in the actual reactor safety documents, and it was written based on the requirements of whatever task preceded the test. Only after the disaster was a 700 megawatt restriction introduced, and the article authors quote something from the Kurchatov Institute of Atomic Energy, where experts apparently found Chernobyl instructive in that RBMK reactors were especially dangerous at low power levels. Here we would like to show another comment from our Kurchatov Institute viewer. He claims that, in general, instructions were written in such a way that even at the Kurchatov Institute of Atomic Energy, his lab would experience an incident on a monthly basis, which he could tell from as early as laying eyes on the street cleaning trucks used to remove radioactive and chemical dust from the nearby streets of Moscow on his way to work. The difference between these regular incidents and the Chernobyl disaster, aside from scope and severity, is that only the former were actually about an absence of safety culture. The Chernobyl operating instructions literally did not even include restrictions made up after the disaster. The man who chaired the commission that wrote the Annex 1 report of INSAG 7, Nikolai Steinberg, wrote in his book that he found the extent of the post-disaster spin job shocking. That is Chernobyl in a nutshell. But it gets even better. At the beginning of the second and final paragraph, the article authors write on this operating violation allegation. They pose the question, what exactly was the difficult control state of the reactor at low power? You see, even though on pages 63 and 64 of INSAG 7 there is a subsection literally titled I4.6.1, Period of Normal Operation and Preparations for the Tests, and there's a paragraph literally stating that what was happening before the test was actually normal. People are liable to thinking that what Soviet experts were uncontroversially referring to, when it came to unstable operation, was stuff like triggering of the fast-acting system for dumping steam to the condenser, manual control of water level in the steam-separated drums, overcompensation of the reactor, etc. Well, that is in fact not what the Soviet experts were referring to. The vague expression of difficult to control reactor at a low power level that Soviet experts put down in writing was subsequently fleshed out into being the presence of a positive power coefficient of reactivity, or the reactor being able to accelerate. How do we know this for sure? Maybe the article authors are unreliable. Behold the Safety Series number 75 INSAG 1 summary report on the post-accident review meeting on the Chernobyl accident, report by the International Nuclear Safety Advisory Group. This is the IAEA report that resulted from the 1986 Vienna meeting and subsequent in-person discussions between Soviet and international experts. Now watch this. Page 3. The net effect of a power change depends upon the power level. At 700 megawatts, the net effect turns positive, and therefore operation of the reactor below 700 megawatts is restricted by operating procedures. That's at the beginning of the report. Maybe by the time you got to the end of it, you hit your head and forgot about the single most important thing, the reactor being able to accelerate. Not to worry. Here's page 77 of the General Observations and Provisional Conclusions section. At the very first safety level of reactor design is inherent stability. What the hell does that mean? It means not having a positive power coefficient, signifying the reactor can accelerate. There's that net effect term again. Again, the report states the net effect becomes positive under 700 megawatts, and, the operating procedures restrict operation under 700 megawatts. But let's say you're really special, and you want some meat between the top and bottom buns of the report. No problem. This is a Swiss sandwich of disaster, meaning the crap is there throughout. Here's page 29, where we learn that 700 megawatts is a level set to avoid the reactors being operated in a condition where an increase in power results in a still larger power rise. Here's page 15. Continuous operation below 700 megawatts is forbidden by normal safety procedures. Here's page 16, where we have the power coefficient defined as the parameter that governs overall stability, and where Soviet experts were apparently trying to hedge their bets, aided and abetted by international experts, which is a tangent we'll go on later. Here's page 19, where it is explicitly stated that the 700 megawatt power figure found in the testing program was merely chosen in reference to the power restriction of operating the reactor altogether. There are two giant problems with all of this. Here is the bottom of page 10 and the top of page 11 of INSAG 7, the later International Atomic Energy Agency report, in which we learn that nuclear experts can do it all, from building to exploding nuclear power reactors. Except use the 3 to 4 letter word, lies. So it turns out this claim repeated again and again in the INSAG 1 report regarding a minimum level of continuous reactor operation existing at 700 megawatts to prevent the presence of a positive power coefficient of reactivity was based on oral statements made by Soviet experts during the week following the Vienna meeting. That's rich. But in fact, and what Soviet experts left vague in writing, there was no such restriction in operating instructions and regulations. Now, how can that be? Let's scroll to page 36 of the same report. The first half discusses the high positive void coefficient, whereas in the second to bottom paragraph, it mentions the positive power coefficient. This paragraph states that measurements indicated there was a positive power coefficient of reactivity, or a self-acceleration property, at power levels greater than 1600 megawatts. This strangely terse statement is a reflection of Deputy Chief Engineer for Science and Nuclear Safety of the Chernobyl MPP at the time of the disaster, Nikolai Karpan's table, which shows a positive power coefficient appearing not in association with low power or the number of control rods present in the core, but in association with high fuel burn-up and the removal of additional absorbers as mandated. So yeah, that ain't good. Even more so than the operating reactivity margin control rods fiasco, this may be the biggest lie of Chernobyl. Yet, how often do you hear anyone even mention such a thing as a power coefficient of reactivity? It's usually HER, positive void coefficient of reactivity, because cheap. Anywho, here's the great wall of text the article authors decided it was a good idea to present in writing on the third violation allegation levied against the operators by Soviet nuclear power experts. You wouldn't put a baby to sleep reading this. You'd kill it dead in its crib. Oh where could my baby be? But we digress. The article authors claim that the official wording of this violation allegation is connection of all MCPs to the reactor with excess of costs for individual MCPs established by the regulations. MCPs stand for the main circulation pumps providing coolant flow to the reactor core. Let's underscore the weirdness of this wording by referring to the actual 1986 Soviet report to the Vienna meeting, which includes a comma for further strange delineation. Connecting of all the main circulation pumps to the reactor, with individual pump discharges exceeding the levels specified in the regulation. Do you see how within what is supposed to be a violation, there is an actual explicit violation? We call this the 2-for-1 Soviet bundle, where you gain remarkably less than you bargained for. How? Let's return to the article. The consequence of the 2-for-1 Soviet bundle supplied by Soviet nuclear power experts is the temperature of the coolant being close to boiling throughout the circulation loop. The article authors immediately point out that the connection of all main circulating pumps to the reactor at any power level before the disaster was not prohibited. As with the power level, a restriction appeared only after the disaster. There was indeed a violation in the flow rates of individual main circulating pumps, the part after the comma. However, such a violation was associated with the phenomenon of cavitation, which, as far as we can tell, has something to do with steam bubbles. Regardless, the potential consequence of this violation meant that the coolant supply coming from individual pumps could be disrupted. As the article authors point out, referring to scientists at the Kurchatov Institute of Atomic Energy writing their own reports, cavitation and disruption of coolant supply did not occur. This was an important topic to consider, as it was floated as a potential cause of the Chernobyl disaster, but objectively dismissed as such. The main circulation pumps simply kept working. Again, we find the parallel of this in the INSAC 7 report at the bottom of page 77. The paragraph explains that the connection of all MCPs was a part of the testing program and operators violated no documents in following through with this action. There was a violation in the individual MCP flow rates, but this did not result in cavitation and the pumps worked without disruption. So, the actual violation of excessive individual MCP flow rates was not a root cause of the Chernobyl disaster. But Soviet nuclear power experts were clever and did not list cavitation as the proposed consequence of a violation. Instead, they listed the temperature of the coolant being close to boiling as the significant consequence of a violation. The temperature of the coolant being close to boiling at the reactor core inlet is something we see in INSAC 7 as well. But not only did Soviet nuclear power experts deceptively bundle the inconsequential violation of excessive individual MCP flow rates with the non-violation of connecting all MCPs, they did not admit the coolant being close to boiling was a natural state of RBMK reactors, that was furthermore acknowledged in operating instructions. There apparently was a danger in the large total rather than individual MCP's flow rate, and therefore, in the connection of all MCPs, but at the time of the disaster, neither the total flow rate nor the connection of all MCPs was restricted. In other words, operators following the operating instructions could set themselves up for disaster. In his Nuclear Engineering International article, How It Was an Operator's Perspective, principal Chernobyl scapegoat Anatoly Dyatlov writes the following. The experiment required no special operating conditions at the plant. 4 main circulating pumps, MCP, in each of the plant's 2 loops were to be operated instead of the usual 3 per loop. But such operating conditions occurred frequently during pump tests, after repairs for example, and were included in the operational instructions. In his other article, Why INSAC Has Still Got It Wrong, Dyatlov again invokes operating instructions. The reactor is operated only in boiling mode, and according to the regulations, may be operated with minimal or even zero subcooling. See Regulations, Chapter 9. This condition is obligatory, since such operating conditions cannot be avoided in principle. They occur with any rise in power, when the pressure falls in the separators. This inevitable RBMK reactor state of minimal or even zero subcooling, or the coolant being close to its boiling point, is actually acknowledged in INSAC 7. Bottom 2 paragraphs of page 64. The thermal hydraulic operating conditions of the core were characterized by low level of subcooling of the coolant below the boiling temperature, 3 degrees Celsius, and a correspondingly low steam quality, which was observed only in the upper part of the core. Under these circumstances, in view of the low level of subcooling of the coolant below the boiling temperature, a small power increase, for whatever reason, could result in a much higher increase in the volumetric steam quality in the lower part of the core than in the upper part. Before the tests, the core parameters were therefore such as to increase the reactor's runaway susceptibility in the lower part of the core. The Commission believes that this situation was created not only as a result of a higher than normal flow rate of coolant through the reactor, because 8 instead of the usual 6 MCPs were in operation, and an increased flow rate prevents steam generation, but primarily as a result of the low reactor power level. Similar thermal hydraulic parameters could occur during any power reduction of the reactor. Even the doofuses writing the opening international section of INSAC 7, who try their best to correct blatant falsehoods while preserving what threads they can to blame the operators, discordantly include the following sentence on page 8. In addition, owing to the lower reactor power level at that time, the core inlet coolant was only slightly subcooled, and, depending on the exact settings for feed water flow and recirculation flow and the pressure distribution in the system piping, may not have been subcooled at all. The international dipsticks don't include the connection of all MCPs and the total flow rate in their stunning list of corrections in subsection number 3, ironically called the accident. The accident here being that Soviet nuclear power experts clearly created an entire false narrative, rubber-stamped and promulgated by international experts in INSAG 1. On page 18, however, they acknowledge the corrections the Annex 1 section makes. So, what's the takeaway? Soviet nuclear power experts were throwing a knuckleball, or something, a pitch that moves in the air. Wikipedia defines a knuckleball, or knuckler, as a baseball pitch thrown to minimise the spin of the ball in flight, causing an erratic, unpredictable motion. Sometimes you just toss a dead ball and let the spin occur in the batter's mind. These masters of deception just combined the non-violation of all MCPs being connected with the inconsequential violation of individual excessive MCP flow rates, that they even tipped everyone off to with their use of a comma and specifying a violation within what is supposed to be a violation, and married all that with the consequence of the water being close to its boiling point that was actually a normal state in an RBMK reactor, acknowledged by the operating instructions they did not provide to the Vienna meeting. How do you like them apples? Do you know who likes apples? Janez Prograd. Now, Janez, on the 14th of April 2025, Control-F'd Xenon in INSAG 7, posted several results, and concluded that we are full of shit. For some reason, Janez also decided to involve episode 5 of the HBO miniseries into this, to which we counter with like a 4-hour analysis of episode 5 with plenty of INSAG 7 quotes. That aside, Janez's collection of INSAG 7 quotes is considerable, for it does make the video they are posted under kind of look like it's full of shit. We say this. We were Control plus F'ing Xenon in INSAG 7 6 years ago, in 2019, and then we actually read and wrote about the document multiple times over. Now, we will do a follow-up to the Xenon poisoning video, but let's at least demonstrate a difference between Control F'ing Xenon for the first time, and having Control F to Xenon so many times, we're practically married to it. Reading from the quotes on pages 11 and 14 of the international section of INSAG 7, the operators had been accustomed to regarding the lower limit on ORM as necessary for control of the reactor's spatial power distribution, but they were not aware that it had safety significance by virtue of the increase in positive void coefficient as the ORM was reduced. The ORM is expressed in terms of the number of equivalent control rods of nominal worth remaining within the core. The definition is not precise, and the importance of the quantity for the safety of the plant seems to have been poorly understood by the operators. It was widely believed that the importance of the ORM centered on the need for a number of control elements in the core adequate for maneuvering to keep the power distribution balanced throughout, especially in the light of the tendency for xenon instability in such a large and loosely coupled core. Yet the magnitude of the ORM was not conveniently available to the operator, nor was it incorporated into the reactor's protection system. In the discussion of the scenario, the operators seemed not to be aware of the other reason for the importance of the ORM, which was the extreme effect it could have on the void and power coefficients. Remember how we just talked about the paramount safety importance of there not being a positive power coefficient of reactivity, because that meant the reactor could accelerate. And remember how Soviet experts lied that under 700 megawatts was when there was a positive power coefficient, and that, of course, general reactor operating instructions forbade continuous operation under this power level. This ORM nonsense in the international section of INSAG 7 is just a continuation of those lies. Obviously, INSAG 7 corrects and refutes most of the INSAG 1 false narrative that Soviet experts fed and manipulated. But rather than INSAG 7 writing, "Oops, we effed up," nuclear power experts just couldn't help themselves but continue to be clever. So, with everything almost corrected, one of the few remaining things to blame on the operators was the operating reactivity margin, or the number of control rods remaining in the core. INSAG 7 uses the well-known 6 to 8 rod figure. Ironically, if you were to look at the timeline found in INSAG 1, you'll see a description of control rod movement associated with feed water flow changes starting from about 119. This movement shows the ORM changing. More than that, increasing the closer you get to the actual disaster. Furthermore, there's an entire graph or chart including rod movement prior to the pressing of the AZ5 button that clearly reveals the transient nature of the 6 to 8 figure that was not current when the button was actually pressed, and hence when the ORM actually mattered. The figure was invalid. The ORM was higher than that, possibly as high as complying with regulations. When you look at the timelines in the INSAG 7 report, you'll find no mention of these feed water flow changes and their effect on ORM. Now what's up with that? In this vein, the international section of INSAG 7 picks up the discredited mantle of blaming the operators for the positive power coefficient of reactivity, and puts it on the ever-broadening shoulders of the operating reactivity margin. Yet, the same as Janez Prograd, the authors of the international section of INSAG 7 apparently never laid their eyes on page 36 of their own report. This page reveals that, along with the power level argument, the ORM being responsible for the positive power coefficient is nonsense. The excessively high positive void coefficient of 5 bananas was associated with an authorized operating reactivity margin, twice as high as the minimum of 15. This high of a positive void coefficient was in turn associated with a positive power coefficient. In other words, if you're just control-Fing stuff in INSAG 7, you can still be the one full of shit. Happy Chernobyl week.